Hey guys, welcome to CodeChef's YouTube channel. The problem that we are going to discuss today is positive spewing. The problem appeared in Starters 11 of September 21 and has a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. We are given a circular array of length n that is containing n elements such that they are arranged in a circle. So if we consider a circle like this, there is element a1, then element a2, a3 and so on, and the last element that is an is present besides a1. So all the elements are present in a circle, the definition for which is given over here. Now, at the end of each second, the following changes are executed in the array. If there exists a non-zero element, so for all non-zero elements, the elements that are adjacent to it are incremented by 1. So let's say there is a element over here, some AI element which is non-zero, then in each second, at the end of each second, its neighbors will be incremented by 1, that is their value will be changed by plus 1. So you can see the example given over here. Initially only 2 and 5 are the non-zero elements. So after first second, these two elements will become 1 and these two elements will become 1, because remember it is a circular array. So it is given that after 1 second this will be the state of the array. Similarly, after 2 seconds this will be the state of the array. So like this the operations will keep on going, but for how many seconds? So we are also given one more number in the input, that is k. So our question is based on this, that is what will be the sum of the elements present in the array A after k seconds. So the initial state of the array is given to us and also the value k is given to us. So we have to perform these changes, that is the adjacent elements of non-zero elements will be incremented by 1 for k seconds. Okay, so k times we have to perform these operations, and finally whatever is the state of the array we have to return the sum of all the elements. So this is pretty much the question. I hope you guys have understood it. Now let's see how to approach the solution. So the solution approach goes as follows. Definitely, we are not supposed to exactly simulate the process. That is, if we try to simulate the process, we have to iterate the array again and again k times. So it is definitely going to exceed the time complexity. So rather, let's just focus on finding the actual answer. Okay. So first point that comes to my mind after reading the question is that if there is a non-zero element, let's call it the ith element. If this element is non-zero, then in the next second, it is going to contribute plus 1 to the element on the left and plus 1 to the element on the right. So if an element is non-zero, it is definitely adding plus 2 to my sum, right? Whatever is the total sum of the array initially, after 1 second, definitely the sum is going to be incremented by 2. Why? Because this element was non-zero. So similarly, if there are x non-zero elements in my array right now, after 1 second, so this is, let's say, some t is equals to j, then at t is equals to j plus 1, if there are x elements right now which are non-zero, then definitely at t is equals to j plus 1, the sum will be incremented by the value 2 into x, because each of them is going to contribute 2 to my sum. Okay, so this is one point to observe. Now once we know this thing, now you might be thinking that okay, we can easily calculate the answer, but there can be some zero elements as well, right, which are eventually going to become non-zero. So the array is not just consisting of non-zero elements, it might contain some zero elements as well. So let's say the array looks something like this. There are some elements that are 0 and there are some non-zero elements. Okay, let's denote them with x. Okay, 0 x 0 0 x. Okay, like this. So these elements, from the very first second, they are contributing to my answer by incrementing the sum by 2 every second. Okay, but the other elements, they require some time to become non-zero. Like for example, if you see this element will become non-zero after the first second is over, because after the first second, uh, because of the element on its left, it will be +1. Because of the element to its right, because it is non-zero, again it will be +1. So after first second is over, how will the array look? The array will look something like this. This will be, I don't know, I'm just looking at this element. So this element will definitely be 1. This will remain x. This will become 2. This will be x, then 1, then 1, then x, and so on. So we don't know. Okay, but the thing is, because of these non-zero elements, this element, the neighboring elements are changing, right? As you can see. So each zero element requires some minimum time to become a non-zero element. And after it becomes a non-zero element, now they also start contributing to our sum, right? That is, each second they increment our sum by +2. So what we need to do is, we need to find the minimum time each element requires to become non-zero. So you might wonder that what will happen of those elements that are already non-zero. So very easy. If I make this array, let's call it minimum time. So min time. Okay. So this is the array. So for elements that are already non-zero, the min time is 0. That is, in the very beginning, they are already non-zero. So for them, the value is going to be 0. For rest of them, we need to calculate the answer. Now, once we have this array with us, that is the minimum time array, we can easily calculate our final answer. But first, let's see how to find the values for this array min time. So let's understand through an example how we will calculate our min time array. So I have an example over here where there are total 10 elements. These are the indices, that is from 0 to 9, and the elements present on index 2, 5 and 8 are non-zero elements initially, okay, in the given array. Remember that I am using a zero-based indexing, so keep that in mind. These three elements are the only ones who are non-zero, rest all are zero. Okay, on a circle it is going to look like this. So I have drawn on a circle as well. So if I try to write them in a straight line, okay, only the non-zero elements, the positions, they will appear like position will be 2, there will be a position 5, and there will be a position 8. But the index 0 and 1, let's say if I draw them slightly down, so 0 will come over here and 1 will come over here. So for 0 and 1, the element, the nearest non-zero element on the right is 2, but on the left it is 8. Okay, so instead of 8, what I can do is, 8 is actually, if you see, it is -2 if you talk in terms of the indexing. Okay, so if in positive it is 8, then in negative terms it is -2, right? Similarly, after 8, the next index is 2. So if the circle would have been continued, this index would have been 12, right? So remember, these are the two extra indices I am adding, okay, -2 and 12. These are the extra indices I am adding, but how it is going to help me? Now see, I can place all these zero indices in between these indices. Like for example, 0 and 1 I have placed over here. Okay, 3 and 4 will come over here. 6 and 7 comes over here, and 9 will come over here. Now for each of these indices, I just have to check which is closer. Is -2 closer or 2 is closer? Again, for 1, which is closer? Is -2 closer or 2 closer? And that can be easily done using a two-pointer approach. I'll just keep 2 pointers, one over here and one over here. So let's call this the pointer L. Let's call this the pointer R. So I'll just see to current index, is L closer or is R closer? Depending on that, I can find the minimum time of 0. So for 0, both of them are equally closer. So for 0, the minimum time let's draw that in blue color. So the minimum time for 0 comes out to be 2. Okay, so in 2 seconds 0 is going to become non-zero. Okay, so element at index 0 is going to become non-zero. For 1, definitely 2 is closer. So the minimum time is going to be 1. Now for index 3, again for 3, 2 is closer. So minimum time is 1. So we have to just compare the nearest two elements. Okay, the two pointers will also keep on going forward. That can be easily done in the implementation. I hope everyone can understand that. Just the point is that the two pointers will represent the nearest left non-zero element and nearest nearest right non-zero element. And amongst these both, we have to choose which is the closer one. That will determine the minimum time. Okay, so for each of them, we can find the minimum time. For these indices 2, 5 and 8, definitely the minimum time is going to be 0 because they are already non-zero. Okay, so once we have the minimum time, how to find the answer? We have to just iterate in the given array. For I is equals to 0, I less than n, I plus plus, answer gets incremented by 2 into, okay, I'll just write this above. So answer gets incremented by 2 into max of 0 comma k minus minimum time. Let's call that minimum time as t. Okay, so the moment it becomes non-zero, from that second to kth second, it will contribute to my answer. And how much it will contribute? Each second it contributes 2. Why? Because the neighboring two elements are added plus 1. So from t second to kth second, it is going to contribute. And of course, if the element if it is taking a lot of time to become non-zero, then t will be bigger than k. So in that case, it will not contribute. Hence, we have to write max of 0 comma k minus t. So once we have our minimum time array, we have to just run this for loop and we get our answer. And the initial value in the answer variable is going to be the initial sum of the array. Okay, we just add the increment operations. The initial sum will be as it is, and then we just add the increments that are brought by the changes. So that is the solution approach. I think you must have got it by now. It will be more clear when we see the implementation. So the implementation goes as follows. First, we take the input for n and k, that is the size of the array and the k seconds. Then I create the array. I also create a boolean variable all 0, because if all the elements in my array are 0, then no matter what the value of k is, the elements are never going to change. So I take the input for the array and at the same time keep a track whether all the elements are 0. If all elements are 0, then definitely the answer is going to be 0 irrespective of the value of k. So I just output that and continue. If not, I have to calculate all the things that I discussed just now. So first I create the min time array that is of the size n and the pos array. So the pos array stores the positions of non-zero elements. So for all the non-zero elements, I push back their positions, and then there are these two lines. What are these lines? So remember how I added two extra positions in the left and in the right of the array. As you might have seen over here, this -2 and 12 are not the positions present in my initial array, but still I am adding them. Why? Because of the circular array, right? So each element should have some element to the left and some element to the right. So because we are processing in a linear fashion, but still we want to take care of the circular array, I am adding these two extra indices, that is -2 and 12. So -2 represents 8, whereas 12 represents the index 2. Okay, in a circular fashion. So I add them. So pos 0 is basically the last index minus n, but uh, yeah, this is the one element that I add extra, and this is the another one, that is n plus the first non-zero element. So after that is done, I create my pointer, that is l is equals to 0, and the two variables L and R as discussed. So again I iterate in my array. If the element is non-zero initially, no use, I just continue. I have to only calculate the minimum time for the ones that are initially zero. Okay, so yeah, so for the ith element, I for sure know that the element present at index I is 0. So I bring the left pointer to a position where it is less than I. Like for example, here if you see, if my current index is 1, then my left pointer should be at such a position that this minus 2 should be less than 1. The left pointer cannot exceed my current index. Okay, and the right pointer will be just the one next to it. So while pos L plus 1 is less than I keep on doing L plus plus. Then my left pointer, my left nearest non-zero element is present at pos L. The right nearest element, non-zero element is present at pos L plus 1. And I just find the minimum time in the following way. That is minimum of R minus I, comma I minus L. This is the only part which you need to focus. The other things are self-explanatory. Uh, I think you may need to pause the video and try this on paper why this works. But once you have understood these two lines, that why I am adding two extra indices, understanding this is not an hard part. So once I have the minimum time for all the indices, I just create my answer variable, which is initially the sum of all elements. So I just made use of inbuilt accumulate function in C++, and after that I just iterate a for loop, and for each index answer plus equals to 2 into maximum of 0 minus 0 comma k minus minimum time. So each index contributes to how many times from the time it became non-zero to the kth second. For these many seconds it contributes 2 to my answer, and finally I just output my variable answer. So that completes the implementation. I hope you guys understood it. If you have any doubts, you can post them in the comments below. I'll make sure to answer as much as I can.